7.6, part 3. Today we're going to deal with a wonky negative. Sometimes certain equations have this negative out in front that can make life super complicated. Like, oh man, my iPad froze up. Sorry guys. It's not letting me switch page. There we go. Sorry. Like this guy. Okay, so this has got a negative out in front. It's got a negative 4x squared. If we were to attempt to guess and check this one like we did the last problem, it would make it not impossible, but more difficult. So we want to try to make these as easy as possible. So if my leading coefficient, if your leading coefficient is negative, factor it out. Okay, what I mean by that is I'm going to factor a negative 1 out of all of these. So I'm looking negative 1 times what gets me negative 4x squared? Well, positive 4x squared. Negative 1 times what is going to give me this negative 8x? Well, that would be positive 8x. And then negative 1 times what is going to give me the positive 5? Well, that's going to have to be negative 5. So now if I distribute this negative 1 into here, I will get back to this original. I'll have negative 4x squared, negative 8x, negative 1 times negative 5 gives me the positive 5. So now what this does is this gives us a simpler trinomial to factor. Again, we can't forget this negative 1 out here. He's just going to kind of follow along just like here our 5 did, just like our 5 kind of followed along. This negative 1 is going to follow along. So now I'm going to guess and check this guy right here. So I want what multiplies to give me 4. So we've got 1 and 4 and 2 and 2. And then what multiplies to give me that negative 5. So we've got negative 1 and 5 or 1, negative 5. Really, those are our only options. So now we're going to go ahead and we're going to try some. So I'm going to try the 1 and 4 first. So 1x and 4x. And I don't know, the negative 1, positive 5. And then we're going to check it over here and see what happens. Okay, we get 4x to the second plus 5x. Again, that's a negative 1, negative 4x minus 5. So I get my 4x squared. My middle terms end up being 1x minus 5. Well, that didn't work. I want to get an 8 in the middle. So that one didn't work. And switching the signs isn't going to work. So maybe we'll flip-flop and put the positive 5 with the x and the negative 1 with the 4. And check that out. So we have 4x squared. Okay, that one didn't work. Nope. Okay, so we have 4x squared minus x plus 20x minus 5. So, 4x squared plus 19x minus 5. Okay, that one didn't work either. So, nope. All right, let's try, what about 2 and 2? Go ahead and try. So we tried the 1 and 4 with the negative 1, 5. Why don't we try 2 and 2 next? So we'll go 2x and 2x. Still, I don't know, minus 1, positive 5. Let's check it. So 4x squared plus 10x minus 2x. Hey, I think it's going to work. Minus 5, because if you notice, this middle term is 8x, which that's what we were trying to get to, a middle term of 8x. First term and last term still work, 4x squared, negative 5. The 4x squared worked, the negative 5 worked. All right, so we found it. Yay! Check. We found it. So now, don't forget that negative 1 out there. We've got negative 1, 2x minus 1, 2x plus 5. Okay. The whole purpose of factoring is to be able to solve. Meaning, if this was set up equal to 0, I could solve it. Okay. This isn't set up equal to 0, but if it was, I could solve it. So we can solve problems like this next one. Here, example 5. The length of a rectangular game reserve. So I'm going to go ahead and I'm going to draw myself a rectangle. Ooh. Close. The length of a rectangular game reserve is 1 mile. The length is 1 mile longer than twice the width. We don't know the width, but here we know the length, which tends to be the longer side. In a rectangle, it doesn't really matter. But the length is 1 mile longer than twice the width. 1 mile longer means 1 mile more than. Twice is 2 times the width. So I want this length to be 1 more than 2 times the width. Okay. The area of the reserve, which is length times width, is 55 square miles. Miles squared. Or we can write that as square miles. What is the width of the reserve? Well, I would have to take the length times the width to get that 55. So the length is 1 plus 2w times the width, which is w, and that has to equal 55. You might be like, well, where does that fit in with all this factoring stuff we've been doing? If you notice, this is already factored, kind of, but it's equal to 55. The zero product property only works if you're equal to 0. So I'm going to have to get this equal to 0 first. So I'm going to distribute this w into both of these. So I'd get 1w plus 2w to the second equals 55. And then I'm going to subtract that 55 from both sides. So over here I get a 0 like we want. And I'm going to rearrange over here. So I'll have 2w to the second, put it in standard form, then plus w minus 55 equals 0. Now that I have it set equal to 0, you always want it equal to 0 to use the zero product property. Now that it's set equal to 0, I can factor it. Because to use the zero product property, it has to be factored. So I need to factor this. So I go back to the methods that we've been using. I want what multiplies to give me that 2w squared. Well, that's just 1 and 2. That's nice. What multiplies to give me 55? Oh, negative 55. We're looking at negative 1 and 55. 2 doesn't go into 55. If you're not sure, try it. 55 divided by 2. Okay, 3 I don't think goes into 55. Okay, but 5 does, and 11. Okay, so now I'm going to have to do some guess and checking to see which one of these work. So, well, for the 2, I really only have one option, a w and a 2w. And I have to decide, well, which one do we want to work with first? I want to get a small number in the middle. It's a 1w here. So I'm going to pick the smaller of these two here. The smaller of the two is the 5 and the 11. They're smaller than the 55. So I'm going to do minus 5, positive 11. One of them has to be negative to get negative 55. And then we got to check it. So over here, I'm going to check it. Let's multiply it out. W times 2w, 2w to the second. W times 11 is 11w. Negative 5 times 2, negative 10w, negative 55. 2w to the second. Let's check middle term. 11 minus 10. Hey, is 1w. Did we find it on first guess? Looks like we did. 2w squared plus w minus 55. Okay, but we're not done. Yay, check. Woohoo, we have it factored. But now it's equal to 0. So now we set each of these factors equal to 0. W minus 5 equals 0, or 2w plus 11 equals 0. We're using stuff from previous sections. Here I have to add 5 to both sides on this first one, so w equals 5. And subtract 11 over here. Divide by the 2. W equals negative 11 over 2, which decimal would be appropriate for talking about length, negative 5.5. But we're talking about width. Does it make sense for the width of this reserve to be negative 5.5 miles? No, this one does not make sense in the context of this problem. So the width, we would say the width is 5 miles. Ask ourselves, does it make sense for a wildlife reserve to be, a game reserve to be 5 miles wide? Sure it does. And we can even find the length if we wanted to. 1 plus 2 times 5, 11 miles. Yep, it makes sense for a game reserve to be 5 miles by 11 miles. Okay. Now your practice. Final practice, page 395, 18 through 36 even. Please see me if you need help, and good luck.